Hello, so I am going to be demonstrating fission and fusion. This demonstration would be shown at the beginning of the lesson to encourage to start getting students interested in actually investigating fission and fusion. So in front of me here I have a bowl. In the bowl, I have 2 cups of water, 1 cup of Ajax, and then I'm going to put in half a cup of syrup. So the original experiment calls for glycerin. However, I don't have glycerin, but corn syrup is an alternative to glycerin, and there is a lot of corn syrup in syrup. So that is what we're going to put in here as well. This just makes the bubbles stronger. Have a nice mixture. So we can test out the mixture to make sure before we see if the bubbles will. Yep, I see one. Okay. So also the original experiment required for 2 circular wire frames. However, I didn't have those either. So I cut out the top and the bottom of cans, so as an alternative as well. So now that we have our soap solution and our 2 frames, we're going to start off by, oh no, there's a bubble in there, by dipping 1 of our metal frames into the solution. We're going to blow a bubble. Now connect it with the other side. Now you pull them slowly apart. And now we have fission. We have 2 bubbles on each side. We bring it together. You can form 1 large bubble back in the middle. And this is fusion. That is demonstrated to students. I would most likely show it in a much slower process. Afterwards, I would ask them why did the bubbles always stay in a spherical shape? That's just a kind of a question to make a prediction about this experiment. This demonstration with the soap bubbles is only a model for the actual process of fission and fusion. In the case of fission, a very heavy nucleus splits and forms medium weight nuclei, when 2 lightweight nuclei combine to form heavier, more stable nuclei is called fusion. The elements that are missing in the soap bubble model are the neutrons and the energy that is released, and are the neutrons and the energy released during fission, and the protons in every that's being released during fusion. A nuclear source of energy is the nature of the sun, where 4 hydrogen atoms fuse into 1 helium atom, and in the process of fusion, it releases energy to form sunshine. The dangers in using nuclear energy lie in radiation leakages and the doses of radiation that the human being can withstand without being harmed. So some other follow-up questions I'll probably ask the students. Again, so why are the bubbles always spherical? What is missing from this model? What examples can you give of nuclear energy sources in nature? And what are the dangers and the use of nuclear energy. So I've listened to this information. However, I would explain, before I explain any of this to the students, I will ask them those questions first, and then I will tell them what I just explained. So extension activities that students can do, they can test it with different size metal frames and different types of soap solutions to see if it works or doesn't work. In different types of circumstances, much like in real life, when people have to figure out the best solution to create the same process.